Hello again everyone, welcome back to ptet.chemistry channel. So this is the start of this section B question on 9.4, which is just my classification of nitrogen and sulfur chemistry. That includes environmental chemistry as part of AS level chemistry. So there's a lot of chemistry in that phrase, yeah. In these last 10 questions of this Cambridge International A-level type of questions, so it's about comparing statement like this. Okay, where you're given three statements. If 1, 2, and 3 are related to whatever they're asking, that's option A. If 1 and 2 are correct or related to what they're asking, that's option B. 2 and 3, there's C. And if only 1 is correct, that's option D. So in this first question, it's saying that which statement explain why do you use SO2, which is sulfur dioxide, as a food preservative. So this is a factual question. So SO2 is indeed, I don't know why I put question mark there, okay, should have put exclamation mark, alright. SO2 is indeed used as a food preservative because it's an antioxidant, okay, so that is a fact, okay, so I need to highlight that it's a fact that SO2 is used as a food preservative because of its antioxidant property, so it prevents oxidation. If it prevents oxidation, usually we'll check number 2 first, but it's very obvious that it prevents oxidation, so it's antioxidant. It prevents oxidation of alcohol, giving you carboxylic acid. So because it's an antioxidant, it prevents the oxidation of alcohol to give you carboxylic acid. So 1 and 2 are correct. Number 3 is incorrect. So SO2 smells. It smells bad, yeah, okay. You will have seen this in the paper 3 experimental or practical component. Okay, when you produce SO2, which you are supposed to test, you test with a strip of litmus paper dipped in acidified potassium manganate, and that will go colorless, okay, because it will oxidize the SO2. All right, have a look through your paper 3 quantitative analysis, and you really need to know the test for SO2. Okay, so if only 1 and 2 are correct, that is option B. So next question, it's basically about chemistry of chemistry NH3 and SO3, so both of which are nitrogen and sulfur chemistry. So you get solid deposits of ammonium compounds caused by the following reaction. So as you know, NH3 is a base, SO3 is acidic oxide. What you might not know is this is sulfur plus 6, that's the oxidation state, where you have sulfur plus 3 times oxygen, overall oxidation state is 0, so each sulfur is plus 6. And when you get the salt, the anion, and you will have a cation. The cation will be the base accepts a proton, because there's the definition of a base is a proton acceptor. So it's going to be NH4 plus, which is ammonium ion, which you know dative covalent bond. Your ammonia is now tetrahedral, 109 degree, with a positive charge because the nitrogen forms 4 covalent bond, one of which is a dative covalent bond. The anion depends on the acid you use. In this case, is a sulfur plus 6. So the anion you will get is SO4 2 minus, which is also sulfur plus 6, because the overall oxidation state of the ion is minus 2, and you have 4 oxygen. So each sulfur is minus 2 plus 8, sulfur plus 6. And the reason why we form sulfur plus 6 here is because, well, there's no change in oxidation number, because this is an acid-base reaction. It simply gives you salt and water, but in the case of ammonia plus SO3, you do not form water. In fact, you need water in order to give you the ammonium ion. All right, so these are the type of equations that a lot of students get confused, all right, because they are unaware of like the salt that you form because of the wrong formulation. They are unaware that you need the water in order to get the extra hydrogen to give you the ammonium ion. All right. And yeah, sometimes they just leave the equation unbalanced, which are clearly wrong, okay, if you don't balance the equation. So ionic bond formation is correct. So this is a molecule. SO3 is a molecule. It's a trigonal planar molecule with double bond between the sulfur and oxygen. Because sulfur is in period 3, you can have more than 8 electrons in the outermost shell. Because you are in period 3, you can use the 3s, the 3p, but you can also use the 3d for bonding. That's why you can have more than 8 electrons in the outermost shell. You form ionic bond because now you have NH4+, in fact 2 of them, because you want to balance off the 2 minus charge of the sulfate. There is ionic bond between the positive ions and the negatively charged ions. 2 is correct. Acid-base reaction is correct based on what I said. A base, an acid, the base accept the protons from SO3 dissolving in water as part of your general periodicity understanding. So that give you the H2SO4, which can react with the NH3 to give you the acid-base reaction. Proton accepted, proton donor. Okay. Oxidation reduction is wrong. I've just shown you that this is acid-base reaction. You get sulfur plus 6 going to sulfur plus 6. No change in oxidation number. Only 1 and 2 are correct. Next questions. So when you burn coal, you get gaseous oxides of carbon and sulfur. The sulfur that you will get will be SO2. It won't be SO3 because, as you know, it's very hard to get to SO3. Even in industry, you need catalysts, you need the appropriate temperature as well as the pressure, right? Unless you're in the upper atmosphere, then you get the atmospheric oxidation of SO2 being catalyzed by oxide of nitrogen. You can see a couple of those in the theory level questions under the topical playlist of nitrogen and sulfur. The carbon, however, can give you CO or it can give you CO2. If it is complete combustion, that should be the one that's formed, but incomplete combustion can give you carbon monoxide. Yeah? So what you could do is you can prevent such pollution by adding calcium carbonate. So as you know, carbonate reacts with acid, but it can also react with acidic oxide. Okay, because acidic oxide is acidic, so it can react with carbonate to give you salt, yeah, plus something else. All right. So what will be important to reduce atmospheric pollution? If I look at equation reaction 2, calcium oxide, which is basic, reacts with SO2. This is called the flue gas desulfurization. I think I mentioned in the other video, back when I was doing my O-level, which is year 11, that is equivalent to GCSE, I guess. We used to learn flue gas desulfurization. So this is the gas given out by that process, and we want to make it cleaner from the power plant. Okay, so this is sulfur plus 4. It is an acidic oxide. Okay, you will get a salt. You will get a salt which is SO3 2 minus. That is sulfur plus 4 as well. So sulfur plus 3 times minus 2 give you minus 2. Sulfur is plus 4 then. And you will get calcium 2 plus. The 2 plus and the 2 minus would mean the formula you get is CaSO3. And there is a solid plus the gas give you another solid. What happened is more air, because that is step 1. In the second step, the CaSO3 plus more oxygen give you CaSO4. This is the more air, that is sulfur plus 4. That is sulfur plus 6, because now you have SO4 2 minus. Sulfur plus 4 minus 2 give you minus 2. In reality, you will have known this oxidation step by heart, because you have learned the difference between SO2 and SO3 in general periodicity of the oxides of period 3. Yeah? My equation is not balanced. Now that it's balanced. Alright? So 2 is correct. It will help to remove the SO2 and give you cleaner solid. Okay, this is a solid, and you can remove them easily. Okay. If we look at number 1, calcium oxide react with SO2 to give you calcium sulfide. You see sulfide there? Sulfide is SO3 2 minus. It's sulfur plus 4, and it is indeed the first step of that reaction. Okay, so 1 is correct. Calcium oxide reacts with carbon monoxide to form calcium carbonate. I can tell you that is wrong, because calcium oxide reacts with CO2 to give you calcium carbonate. That is carbon plus 4. This is CO3 2 minus. That's carbon plus 4. You can work it out in the same exercise that I did for sulfur. You can work out it's carbon plus 4 because this is an acid-base reaction. It is not a redox. Okay, so calcium that is plus 2, carbon that is plus 4, oxygen that is minus 2. Okay, so it is reacting with CO2 to give you calcium carbonate. It doesn't react with carbon monoxide to give you calcium carbonate. 1 and 2 is correct. That's option B. In the next question, it's saying which statements are true about Haber process to manufacture ammonia. So we know the Haber process is N2 plus H2, giving you NH3. So that is a gas, and a gas. So to balance the equation, I will need 2 NH3 and I will need 3 H2. Okay? Alright, we know that at higher pressure, the rate will increase because pressure and rate, we talk about the molecules are closer together, they collide more frequently. This is to do with collision frequency from your O-level GCSE, that will increase. As you increase the pressure of gaseous reactant, they will be compressed and they will be closer together, so you collide more frequently, so faster rate. But the yield, because you're in equilibrium, you need to think about 4 moles of gas on the left, 2 moles of gas on the right. Okay, the gas are very important. You can find out how to explain this properly in the A-level topical playlist for AS equilibrium under Le Chatelier principle. Yeah. So the yield goes down because when you increase pressure, the equilibrium will try to reduce the pressure. It will shift to the side with lesser gaseous molecule. It will shift to the right at higher pressure, and therefore your yield will not goes down, it will goes up. Because as pressure increase, the equilibrium shift to the right hand side. Because at higher pressure, the equilibrium will try to reduce the pressure by shifting to the side with lesser gaseous molecules. So it will shift to the right, you will get a higher yield, you don't get lower yield. 2 is wrong, therefore, by logic, only 1 is correct. Okay? So if we go through the other option anyway, so of course once you get the answer, you can move on. But if I just go through the other option, because it's important to understand why they are correct and why they are wrong. At higher temperature, rate is faster because we talk about collision frequency. We also talk about the Maxwell-Boltzmann distribution, how the energy distribution will change as temperature changes. Okay, so your proportional effective collision changes. Both of these are required at A-level explanations, yeah, not just collision frequency. We know the forward reaction is exothermic. So the forward reaction releases heat energy. When you increase temperature, the forward reaction will try to oppose the change. It will release less energy because you want to decrease the temperature. You will release less heat energy. How do you release less heat energy? It will shift to the left. When you shift to the left, you will get lower yield of the product. So the yield goes down. That is correct. Okay, but we know that's correct already because number 2 was wrong. In the presence of a catalyst, the yield goes down. This is a incorrect chemistry because the use of a catalyst does not affect the equilibrium yield at all. It only affects the rate. Okay, so that is wrong, but the rate is faster. Okay, so 3 is actually wrong. Moving on to this last question of this section B type of questions for nitrogen and sulfur chemistry. So which one represents stages in the contact process to manufacture sulfuric acid? This is a case study ever since O-level. I think like some O-level syllabus, like the one in Singapore, doesn't include nitrogen and sulfur chemistry, which means they don't do contact and Haber process. I think the GCSE also might not do this, but you know, people who are doing GCSE, you will know your specification and syllabus better than me, and you will know what is and what isn't in your syllabus by referring to your document for the syllabus. Yeah. So people who are doing A-level definitely knows that this is part of their case study. You know that you do not. I can tell you if you check number 2, you do not dissolve the H2O and SO2. Okay, so that's not part of the contact process. There's only one is correct, and there must be D. Okay, because what happened is the sulfur burns in oxygen to give you SO2. There's solid, gas, and gas. And then the SO2, this is the main mate reaction, yeah? So give you SO3, there's gas, gas, and gas. You can do 2, 2, and 1, or I can do 1, half, and 1. Balance equation, yeah? In industry, really, you don't dissolve the SO3 in water straight away. You go via the oleum, which is concentrated H2SO4, dissolving the SO3, give you H2S2O7. This oleum, by going through this oleum, you prevent a disaster happening, that is to do with corrosive H2SO4 fumes all over your factory, and that is really bad, okay, when you dissolve SO3 in water, because that is a very, very exothermic reaction. You're going to get H2SO4, you're going to get 2 of them, 2 hydrogen, 4 hydrogen, 2 sulfur, 2 times 1, 8 oxygen, 7 plus 1, 8 oxygen. Okay, so it goes via these 4 steps. This is to prevent dissolving SO3 in water straight away, because you don't want it to be exothermic and you get a lot of corrosive vapor in the factory. This is the only one that's in equilibrium. You have to think about Le-Chatelier principle. You have to think about temperature, pressure, and the catalyst to increase the rate of reaction. Okay, so option D is definitely correct, based on knowing that this is actually factually wrong. Okay, based on the chemistry. This is the end of this 5-question tutorial on these section B kind of questions for nitrogen and sulfur chemistry. So catch me in my next video on my channel in a few days time. So thank you for watching, and subscribe to the channel if you find the contents of my channel useful. Do share them with friends, your group chat with the classes, your juniors, your seniors in school, I guess. Anyone else you know who might benefit from this channel. Okay, so thank you for watching again.